Dealing with a 30, 60, 90 degree triangle, and so there's two different equations that we could potentially use with this one. Hypotenuse equals the short side times 2, or the long leg is the short leg times the square root of 3. And remember, because you've got two different equations, and because you could have a number of different things listed in the diagram, you might not be able to just guess and use one of them. Okay, so here's what I mean by that. In this equation, I've got the hypotenuse compared to the short leg. Do I know what the hypotenuse is? No, I don't. It's a variable. Do I know what the short leg is? Yes, I do. So I've got a specific value in there. I would be able to use this if I wanted to. Could I have done the same thing over here? Well, I'm comparing the long leg to the short leg. Do I know what the long leg is? Nope, it's a variable. Do I know what the short leg is? Yes, I do. It's a constant. So in this case, it wouldn't really matter which one of these equations I use to start with. It also wouldn't matter if I tried to start using y or finding y or x first. Either one's going to be just fine. Why don't we start with this one over here on the left-hand side. We'll plug y in for our hypotenuse. We'll plug 9 in for the short leg, and we're multiplying that by 2. So therefore, y must be equal to 18. My entire distance up here of the hypotenuse must be 18. When I come over here and try to solve for the long leg, which is going to be x, I can plug that x in for the long leg. I know my short leg is 9, and I'm multiplying that by the square root of 3. That's as far as I would go with that one, unless I wanted to plug that into calculator and estimate it. But I'm going to leave it as a more specific number, 9 times the square root of 3.